Hello, everyone. It's very nice to see lots of faces. My name is Ugur, which means good luck in Turkish. It doesn't bring me good luck when I introduce myself. It's always misspelled, and even on my graduation diploma, it was misspelled, but let's still call it good luck. I'm a PhD researcher at Imperial College London at Department of Bioengineering. And I am a medical device designer, and I'm specializing in artificial limbs, prosthetic limbs. Today, I am going to talk about my research and where it started, what it became, and also the impact of my research, because as we have some amputees, I'm sure here, there is a massive problem with socket fitting. So my research solely focuses on how can we solve this socket fit problem. So I co-invented a technology during my research. I prepared a presentation. I will talk and show some more details about it and its impact on healthcare systems and amputees like yourselves, and also the people around amputees, family and friends. It's a big problem and worrying problem. So this is going to be more an informative session about how we are trying to tackle this problem. So I will share my screen now. So a bit of background for myself. So I'm currently doing my PhD. I'm in the final year. Before I did this PhD, I did a second master's at Imperial College London. That was Master of Research in Medical Device Design and Entrepreneurship, where I have actually co-invented this technology. But actually, originally, I am a biomedical engineer. I studied biomedical engineering in Istanbul, Turkey. And then in 2014, I moved to London to do my first master's degree in advanced engineering design. And in my first master's, I did an upper limb prosthetics, an affordable upper limb prosthetics. Then that led me into the research projects related to prosthetics, and that's how everything started. And during this research project, after inventing the technology, I also launched my startup, because I do not want this technology to remain on a lab bench. I want it actually to get out of the laboratory and reach out amputees. So throughout the research, I'm also cooperating with Imperial to commercialize this technology. And now I'm going to talk about the story of this technology, starting with a very familiar problem. So Peter is an amputee who lost his legs in a bicycle accident in London. And since then, he's wearing prosthetic limbs. And this is a very familiar system to most of you. A prosthetic socket is made of hard plastic, handmade, and not flexible. And this is basically the beginning of the problems. Because when you look at your prosthetic limb, you have very expensive robotic joints. If you're above knee amputee, you will have maybe microprocessor, knee or ankle joints, very precise and sophisticated systems. And then as you go towards the top of the prosthetic limb, you have this handmade socket system, which still uses the same carving techniques that was used in 19th century. There are some few developments, some clinics use like 3D printing and 3D scanning, but vastly it is done by hand. And this is where the problem is starting, because prosthetic socket is the most important part for amputees' daily life and health and comfort. So when you have a very expensive system that is attached to this socket, and when this socket doesn't fit, the whole system does not function anymore. And this is frustrating, because this is a bit like, sometimes I explain this, wonderful, beautiful pair of shoes that is not your size. So when I go to lots of events and engage with people trying to explain what it could be, like an advanced prosthetic system that you cannot actually wear. So really fancy shoes, but that are not your size. And when you try to wear them, it breaks your skin. Because the problem is our bodies change shape throughout the day, but prosthetic fittings don't. Did you actually know that in the end of the day, we are 1.5 centimeters shorter than the mornings? And that's because of the gravity, we actually shrink. And in the end of the day, our feet and hands are larger than the morning. And actually our belly is also larger than the morning. So throughout the day, we are constantly changing shape, a bit like a sponge. But because this is happening so slow, we don't notice these changes. And an easy solution to this, we wear flexible clothes, elasticated flexible clothes, which solves the problem. However, which is logical, but however, when you lose your limb, they give you something that is not flexible. And that's where the problem is starting. For example, Peter wears his sockets in the morning. Few hours later, they start hurting. Few weeks later, with his busy life schedule, the pain becomes unbearable and hurts his skin. He books an appointment, waits for the appointment, go to the hospital. There are some temporary adjustments that the hospital, the clinic can do. At that moment, it fits good. And then a few weeks later, it starts hurting again. To the point that if he pushes him too much, he's going to break his skin, go to the wheelchair, wait for his new sockets to be made. And the new sockets are sadly going to cause the same problem. This cycle repeats up to 4 times. And actually, in some examples, amputees we have spoken is up to 7 times in a year, especially in the beginning. And Peter is not the only one. Every year, 300,000 people in Europe, UK, and US loses a part of their limb, majorly due to diabetes. And 3 out of 4 amputees are unhappy with their prosthetic fittings at some point of their experience. So when we talk, this is a medical and a social issue, because when we talk about a prosthetic limb fitting problem, when it doesn't fit, it is gonna induce some medical complications, such as skin break, sores, pressure sores. And if some people have diabetes, it will be even hard to heal these wounds, and there is risk of infection and secondary amputation because of these infections. And there are further medical complications, even if they are rare, that happen. And on the social side, when a person cannot walk, when a person who is within the employable age range, when they cannot work, they cannot produce, they cannot go to work, state of like have a calm mind to actually focus on what they're doing. They are struggling to look after their family, or if they're carer of someone else, and it becomes an obstacle, a hindrance in their life, so that they have to find a way to tackle this problem. And sadly, most of people, when they reach to when they are 35, the age probability of an amputee walking more than 500 meters is 74%. But when they reach to 60, the same distance, walking 500 meters, the probability drops to 34%. A huge drop. And if we think about mobility as a general well-being, the less mobile amputees get, the more problems they can face in the future. And as a social healthcare system, how do we solve this? Because these people have a life-changing condition, and unless we do something right now, this is going to affect their social life, their activity levels, their family life, and they are going to develop further health issues, which also includes not only physical, but also mental health issues. And here I'm only showing you the cost of socket replacements. is in the US and UK alone is £5 billion. For these amputees sockets to be replaced, the wounds treated, and the staff time for example, NHS needs to put in to actually help to solve this problem. And sadly, the problem doesn't have an end. The problem will repeat next year again. So this is not a 5 billion investment that will stop it. This is an just recurring cost. But the saddest point when I go to the events and talk about comfort issues, sorry to show you, some amputees face as severe as wounds like this. This is not because they had amputation. This is because they don't have a socket that fits to their skin. And evolutionary, our skin, the sole of the feet is evolved to not to be too responsive to pressure. And that's why people can run barefoot and they will not, for a short distance, they're not gonna really feel it that much. However, the leg skin is not evolved to bear pressure. So that's why when there is a contact on the leg skin that presses all the time, constantly, the skin develops inflammation and then causes the pressure ulcer, pressure sore. This is the reason, because when there is an amputation, the body load needs to be distributed across the surface of the leg. Leg skin is not evolved to bear this pressure, and there where the pressure sores are happening, especially when you have poor fitting where a point is pushing more than any other point. That's where the stress accumulates and it breaks the skin. And what if we had a technology that changes shape when the leg changes shape? What if we had a device that is soft enough to provide cushioning and distribute stress points? And what if we had an adaptive liner that goes inside of the socket and uses artificial intelligence to learn those daily changes and adapt to them immediately? So we named it RoLiner, the world's first robotic liner. It uses simple yet unique principle happening inside of these tiny air bubbles. When the leg expands or when the leg shrinks, the air pressure of the bubble changes. And then a control algorithm understands these changes to adapt to them and to keep fitted throughout the day. But more importantly, RoLiner gives the control to the user. So via a mobile phone, smartphone app, amputees can instantly change the cushioning and tightness of the liner and their fitting, and they can save this wherever location they are as a presetting, so that when they want to do running, they can just set into the running mode. And then with their lifestyle and data, this is then learned by the artificial intelligence to be done automatically to reduce the clinical dependency. In high level, this is how it looks like, the components. On the right-hand side, you have a liner that we have designed it in a way that is not going to disturb any amputee's existing system. It is a washable, cut to size liner. It's a silicone liner made of soft silicone. And the liner goes inside of the socket and connects to a control box. A control box is can fit to the palm of a hand, a small box that connects to a mobile phone via Bluetooth. So as you change the settings via your phone, the settings of the liner, and you like it, you give feedback, these are then sent to a cloud and they're saved in the database to study what is your liking at that time of the day, that day of the week, or that week of the month, to learn and start suggesting. Of course, this research is now 6 years old. So when I started, there was no such thing as adaptive liners in the literature. So how do we design something for the first time when it hasn't been done before? And particularly embedding those air bubbles into that liner was quite a tough journey. So initially, we started with the proof of concept on something similar, a shoe insole. Because shoe insole, you can still record the steps, and you can still inflate it. It's a variable structure. So here, as the person starts walking, by the way, this is an old box size. The new one is smaller. As the person walks, you can see the top graphic and bottom graphic looks similar. So the top one is the signal that comes from the toes, the bottom one comes from the heel. And a bit like a heartbeat, it is a stable and predictable signal. And each person has a way of walking. So the way we walk, it's also called gait. The way we walk is a biometric data. It's like the iris scan, facial recognition, fingerprint. You cannot replicate one person's walk. It is unique to that person. And gait data is valuable because it can tell you how the person is walking, because with amputation, you lose your body symmetry, which means you have to put more effort to be able to walk on that symmetric line, so that in the future, the joint health, like the hip or lower back, will not be affected. So inside of Roliner, we embedded some sensors that can also track the motion to tell the amputee whether that walk is a symmetric walk or not, or how to correct it. And these daily insights will be given so that it is going to be a bit like a rehabilitation, but not necessarily in a clinic, but just in your everyday. You will get a notification to correct your steps. So the initial this graph I showed you earlier had the potential to actually track these precise signals. But in general, what is different about Roliner with most of the conventional prostheses is that it gives the user control. It is continuous and predicted adaptation, and it works with existing socket systems, and it collects health data to inform you how you can improve your health. So this working with existing systems was one of our red lines, that we were going to invent something that is going to work with existing sockets, and people are not going to go through a new socket crafting. But also, when this is ready, NHS will not go through a staff training because they are not familiar with the device, or amputee requires extra training because it's kind of like an alien device. So we wanted to make sure the device is very similar to the liners that are out there, normal liners, but also brings the extra benefit. That's why it has taken 6 years. So this is from last September with a volunteer amputee. And as he was walking, you can see on the right-hand side the same sine waves, the peaks going up and down. And each of them are responding to one step. And here, what we cannot actually, if I come here, what we cannot hear is that before he actually activated Roliner, he had a bit of pistoning, a bit of empty space at the bottom of his socket, and he was feeling his socket was moving up and down. So when he activated Roliner, it just stabilized it, and in the end, he says, "Oh, where is? I don't know if it's audible."
Walking with zone 4 in place, so there's no piston at all.
So he says that's working for me with zone 4, which is the bottom zone. Zone 4 inflated, there is no pistoning at all. So the pistoning is the movement of the socket going up and down. So this was the first, after 5 years, this was the first sign. Actually, we were able to get this level of data and this kind of user feedback. But Rolliner is actually not only a prosthetic limb technology, it is an adaptive robotics technology. The same platform can be implemented in upper limb prosthetics, wheelchair seats, patient mattresses, and diabetic foot care as shoe insoles. Because the same pressure occurring, especially with people with diabetes, the problem doesn't come from a prosthetic socket, but the problem comes from the pressure. So the technology will be adapted there. It started in 2016 with nothing. Me and my supervisor, Guder at Imperial, started to look into newspapers, internet articles, scientific journals to see what's the size of the problem, spoken to Charing Cross Hospital, and then created a, let's call it a prototype, not to be rude, but created something that you wouldn't even be in the same room with it initially, but to just show that we can actually put these air bubbles into this soft silicone. And then in 2017, we started to improve the prototype and then start trying it on human skin to see its impact when it inflates and deflates. And then in 2018, we got £200,000 from Research England. It's a research grant to develop the technology. With that, we have hired a software engineer to look into the software and also electronics part. Filed the first patent in 2019. We have been selected as one of the most innovative 15 startups in Europe by European Union and been awarded 612,000 euros in partnership with Imperial College, GE Healthcare, and Cap Digital. And that was for 18 months, and that developed the prototype massively to the point now it became a wearable device. In 2020, Mayor of London, Sadiq Khan, has recognized me as the Entrepreneur of the Year in Health Awards in London, as well as the company and the team. And we have converted the prototype into a minimum viable product. So it started to look more appealing and less product. And in 2021, last year, we got a £500,000 Innovate UK grant from the UK government to look into the manufacturing and early market demonstration, something that looks a bit like actually a product that people can use. And this year we are designing the clinical trials with the NHS at the Charing Cross Hospital. And the goal that the team is working hard, and that's one of the reasons why they couldn't be here right now, is we want to be approved by the MHRA to be in the market to access amputees. The broader team is 5 people. Myself, I explain my background, and Frat is my also PhD supervisor and also co-founder of Unhindr. He was transferred from Harvard to Imperial. He is an expert in robotics and sensors. And then Guglielmo is the software and biorobotics expert, bio-inspired robotics expert. Who is developing the app, the electronics, and responsible for the overall technology. Tarek is the product engineer who designs and 3D prints all the control box and the liner and everything that is basically physical. And Sabrina is a medical student, and he is already an engineer. He already has a master's as a bioengineer, but she decided to study also medicine on top of engineering, and she is looking into the clinical data, how we can relate to this data so that we can teach it to artificial intelligence so that artificial intelligence will learn. The overall project team the project Roliner, is 22 people. And it is thanks to our grant partners from all around the world, especially heavily focused in the UK, to make it happen. And so far we have received industrial interest from prosthetic companies and also prosthetic clinics in the US. And we are looking into collaboration with them towards the end of this year so that we can accelerate things better. And also the technology has received various recognition awards from industry, academia, and these were part of my PhD, and some of them were coming from investors, and some of them were science conferences and institutions. What we do like the most is working with amputees. So throughout this 6 year, we have developed connections with amputees. Two of them are actually World Paralympic champions. David Hansen is a colleague. He was also doing PhD at Department of Bioengineering, who initially helped me when I was not finding anything on the literature, how I'm going to design this. So I was asking my questions to him. In 2016, he won bronze medal for Team GB, and Susie Rogers has 16 gold medals. And we have a growing amputee community around the world. That is at the moment 22 amputees, because when we hear something from them, that just inspires us. So we go to the meeting room and start writing on papers and post-its and start thinking, okay, how can we make a difference from this sentence? If this person has said this, can we include a feature that can actually improve this or eliminate this issue? And that's why we do love working with amputees. And as the word went out, we started to get lots of messages all around the world. People, they in the UK, in US, in Canada, everywhere, they're asking about Roliner, inquiring about Roliner, whether they can get it for their husband, their wives, children, and loved ones. We are developing Roliner because we promised amputees that we are gonna provide them an unhindered life. Because by end of today, 456 more people will never walk again like they used to do. And it could be you, me, or your loved ones. And now here I have a call to make. At the moment, at the Imperial College London, we are doing a user trial here in South Kensington in White City campus. And this trial is open to public. And you can scan the QR code, or the highlighted email is, the highlighted part is my email address. If you would like to try Roliner as part of this research project, and if you're close to London or can travel to London, and the eligibility criteria is, so because there are too many factors, we have to narrow down the variables, the changing parameters, and that's why we have to include this eligibility criteria. So using the same socket for at least 12 months in last 1 year, ability to walk with a prosthesis without any other mobility aids, basically being ambulant on prosthetic leg, using a silicone seal inliner. So that means your socket should have a suction socket, and it could be above knee, below knee, or through knee, but especially above knee, because we have been doing some trials with above knee amputees, so things started to become very smooth. But also we want to also acquire that know-how, that information with below knee amputees as well. So if you fall in under this criteria, and then you can, you are in London or you can travel to London, this trial, what are we looking is, this is an advanced laboratory that has 10 cameras, motion cameras, and there is a walkway that is 4 meters long, and you will be placed some reflective markers on your body, on your joints, and these advanced cameras capture the location of these reflective points, markers on your body, and the system analyzes how you walk on this runway. And the runway also has some force plates. So when you step on them, they also tell you how hard you step. So we can do this comparison, your current liner versus pro liner. Is it any better or is it worse? And I would like to thank Limbless Association also for helping us to reach out wider amputee community, especially David Rose, who was the first point of contact in 2018 when we were invited to an NHS event. That's where I met David, and at that time things were very premature yet, the technology wise, but now we came to a trial stage, and he has been very helpful. Also, Deborah has been very helpful. So this is my opportunity to thank the Limbless Association family for their support, and hopefully our continued collaboration with Imperial College London. So I would like to answer questions, because the most beautiful thing about these kind of engagements is hearing questions, because you never know what you're gonna ask could actually inspire us to do something even better. So thank you very much for your attention and time.